So am I not on video at all then?
No, your camera is not turned on.
Oh, there we go.
All right, it is 8 o'clock. We will go ahead and get started. Good morning, welcome. I'm John Hickman, one of the chief residents, and welcome to the Department of Medicine Grand Rounds. On behalf of Dr. Frazier, Costco, Spencer, and myself, we're so glad you're here, and we have a fantastic talk today. I'm really excited for it. We're really delighted to have Dr. Stephen Lawrence join us this morning. Dr. Lawrence came to WashU for medical school and residency. He then stayed for infectious disease fellowship prior to obtaining his Master's of Science from the University of London School of Hygiene and Tropical Medicine in epidemiology. He currently serves as the Assistant Dean for Curriculum and Clinical Sciences in the Office of Medical Student Education, where he is part of the core team that's building the upcoming Gateway curriculum. He's also a professor of medicine in the ID division. Dr. Lawrence's research interests focus on epidemiology, treatments and vaccines for respiratory viruses, and he's been involved with pandemic and bioterrorism preparedness for more than 20 years. So this work has placed him in a prime position to help us navigate this pandemic. And we are just thrilled to have him here to discuss where we are with COVID-19 and the Delta variant in particular. So Dr. Lawrence, thank you so much for being here. We're really glad to have you. And a reminder to everyone that we're gonna have some time for questions at the end. And this talk and previous talks are available on the Department of Medicine website and our YouTube channel. Dr. Lawrence.
Good morning, and thank you, John, and thank you, everybody. And I'm going to start off with, I'm going to try something new that I would like to do that is in relation to the title for this talk, which we call the Delta Blues, because this certainly the Delta variant has been causing a lot of grief. And also, though, So this is in homage to a very old musical form, the Delta Blues, that originated from the Mississippi Delta about 100 years ago, or a little over that. And given what has been happening with Hurricane Ida and all along the Gulf Coast and even all the way up into New York in the last few days, I wanted to acknowledge that and also make that connection. So beyond that musical experiment, I do want to then just go ahead and get started. And I have not much to disclose other than I am a site principal investigator for one company that is looking at antivirals, but it's not pertinent for this particular talk. I do have some unofficial disclosures, though. First off is that, much of what I say today may be obsolete very soon, in a month or a week or a day. In fact, I just did the VA grand rounds yesterday and have made significant changes just in the last day from new information. The other thing I also have to disclose is that really, I'm not an expert in virology or immunology or psychology, although I'm going to talk about some of these things. But I do see myself as somewhat of an interpreter or a translator of a lot of this information to be able to put it all together in a way to try to have it make sense and to assemble it all. And I guess that's part of my education background as well. And so for the next 45 minutes or so, I wanted to talk about the emergence of variants from an epidemiologist perspective, the impact of this current Delta variant, what these changes have been, how they've related to vaccine effectiveness, and then also offer a few takeaway thoughts that we'll be able to leave on. So first off, the SARS coronavirus type 2, which is, of course, the virus that is the center of attention right now, is one, it's always important from a virology perspective to think a little bit about the structure of it, because the structure defines some of the function, and the function then tells us a little bit about what we can do, certainly from a vaccine perspective, helps us understand, why it does the things that it does and why vaccines work or don't work. And so this is a very nice electron micrograph that shows an actual viral particle. Of course, it's colorized. It doesn't actually have a pink spike protein, but it's just enhanced to be able to show that these are those spike proteins on the surface of the virus. And of course, the spike protein is the most important part for certainly one of the most important for its function, because it is what the virus uses to bind to human epithelial cells on the ACE2 receptor. And you see the major component of that is the receptor binding domain of the spike protein. When there are mutations that occur in these very critical areas, it then does lead to different changes that can affect its function. And it's also the most important protein for a target for antibody-mediated immunity. And so again, mutations that occur in the spike protein, particularly the receptor binding domain, are ones that can have significant impact on our ability to contain this and the virus's ability to evade immunity. And what, of course, in a very simplified fashion that will make our immunology colleagues certainly cringe, but this cartoon, again, just reminds us that either through natural immunity or through antibody-mediated immunity or vaccine-mediated immunity, we develop antibodies that then primarily are useful by being able to be pre-existing and present when you are exposed to virus. It then binds virus and prevents the binding of virus to the human epithelial cells, and thus preventing either infection if there is enough antibody there and a small enough viral load that you may prevent infection altogether, or more likely what happens is that you do still have some cells that do become infected in the upper airways, but that you have enough antibody there that is functional and neutralizing to be able to prevent the progression to more severe disease. And so we actually will go into a little more detail about that. But one of the things that is important to understand is how this virus changes over time. And we have given the term variants to use for this SARS coronavirus type 2 in the past. Say, for example, when we've seen antigenic drift for flu, we just call those, flu strains. But in this case, when there are significant changes that occur in the coronaviruses, that occur because of mutations, we call these variants. And this is very common with RNA viruses. The process by which the virus replicates within human cells causes many mutations to occur. Now, the coronaviruses don't tend to mutate as much as flu viruses do. The process isn't quite as sloppy, but there are still frequent mutations that do occur. Now, most of the time, that has no significance, that those mutations are non-productive, and oftentimes they may even lead to a virus that doesn't even, can't replicate. But sometimes when mutations occur, it does impart some important changes, and it may confer a competitive advantage for those viruses that do undergo mutations that are just, a series of random mutations may spit out a new virus that is more dangerous because of primarily one of three reasons. Either it's more transmissible, say, for example, if it is more readily binds the ACE2 receptor or binds more avidly, or if it replicates much more effectively or quickly so that you get more of a viral load within a particular host, that you then have a more transmissible virus. You may have some changes that affect the virulence so that you end up with more severe disease that is virally mediated, or you may end up with antibody evasion so that your vaccines or prior infection or monoclonal antibodies are less effective. Now, when these happen, the CDC and the World Health Organization have created a system to name these variants. And first off, if they start to see circulation of SARS-CoV-2 that have concerning mutations that have the potential to do one of those three things. They call these variants of interest. And if then some of those variants of interest start to circulate and actually demonstrate those behaviors, not just have the mutations that show potential, but start to actually show increased transmissibility, increased virulence, or antibody evasion, then it becomes a variant of concern. And then there's a category that thankfully hasn't been used yet, is where there's a variant of high consequence that would have a severe public health impact. And what you could imagine here is something that's as transmissible as Delta variant, but also is completely evading our existing vaccines. And that would be considered a variant of high consequence. So how do these arise? And this is, there's a theory and actually some data recently that seems to suggest that more often than not, when somebody is acutely infected, that infection and the time of replication is a relatively short period of time. And that while there are some variants that develop within an individual during a very contained acute infection, the sort of transmission of those variants is very unlikely. There just aren't a lot of them that occur within an individual, and that's likely the case. But we have seen several instances and several very good reports where immunocompromised patients, particularly those who are undergoing B-cell depletion therapy, they can become essentially chronically infected and have replicating virus for weeks or even months. And when that happens, as it's replicating and as there is an ineffective immune response that's being generated with antibodies that are directed to it, but not enough and not neutralizing enough, you end up sort of developing in vivo new variants pretty regularly. And that's where the risk, we think, occurs for the development of more variants. Now, that's sort of on the individual level. When you're thinking at a population level, though, and you have millions of infections that are ongoing at any given time, of course, that even those short instances may be an opportunity for a very rare event for a new variant to emerge. And this is important to keep in mind as we think about how we contain this globally. But so the idea of variants overtaking and really supplanting prior variants is something that we've seen really since the beginning of the pandemic. And it's similar to what we see with influenza as well, when a new, more competitive strain, and especially after a flu pandemic, once it emerges, the prior ones tend to disappear. And we've seen this with SARS-CoV-2. So very early on, the original strains that had come out of China and then were imported into Europe, we saw pretty quickly a conversion at a particular site at 614, where then one mutation occurred at that site, and then it quickly became more competitive and became the dominant variant within Europe. This is before we called these variants of interest and concern, though. This is back in early 2020. Since then, we've now had 4 variants that have reached a level of variant of concern. The Alpha variant we heard a lot about back around early spring. It caused a large surge in the UK, and it became the dominant strain in the US in the spring. But and the reason it did is because it's 50% more transmissible than the prior variants. Now, luckily, it wasn't of higher virulence, and it had very similar vaccine susceptibility, so it didn't evade immunity at all. And very interesting, we didn't see the same impact that the UK did. As you can see, this is the St. Louis region, and this is roughly the time where Alpha was introduced. Now, it's a little unclear if this sort of little spike that we saw as we were starting to come down from the peak in November, it's unclear if that might have been some Alpha that was causing that, or if it was also a combination of everybody, the holidays and then kids getting back to school for the spring semester. But either way, Alpha didn't cause the big spike that it did in the UK. And a big reason for it, we think, is because this is also the time where vaccine rollout was starting to occur, thus implicating that Alpha was very susceptible to the vaccine. And you can see this as well, actually, because Alpha was still the dominant variant all the way through here when the levels got even as low as they did in June. And so vaccine clearly is effective at suppressing Alpha. Now, Beta was a variant that was identified that actually caused a fair amount of concern and still is on the radar of some concern. The first isolates were seen in South Africa. It did cause significant transmission there. We've seen very little of it in the United States, and it has additional mutations within the spike protein that have granted it not only 50% more transmissibility than the original variants, but and luckily not more virulent that we think, but it really has some moderately reduced vaccine susceptibility. So this very much is on the radar screen, because if it ever does become the predominant variant or picks up some additional mutations that makes it even more transmissible and more competitive with the Delta variant, that it could be problematic because it does have some reduced vaccine susceptibility. Luckily, it has not taken hold in the US. But what has is Delta, and that's what this story is all about. You know, we saw the harbingers of it here in the US, you know, that in June, we started to see this really in Southwest Missouri was the epicenter. The Springfield area just got hammered. And you can see we were, you know, their data here, their peak was higher than it was in what was previously their highest peak in the November, December range. You know, since subsequently we've learned that this is about 2 times more transmissible. So the R0, or basic reproductive number, is probably around 6 when no mitigation measures are being used, which is extremely, extremely contagious. And part of the reason for it, in addition to what's thought to be some more enhanced binding to the ACE2 receptor, is that it does replicate without and causes more viral shedding. So any one individual person is shedding about 3 log more virus, and that leads to about double the transmissibility. Now, there's some question about whether it's a little more virulent. There's some data from Scotland that showed that perhaps there's some higher severity of this compared to prior variants, but it's not consistently been shown. It's a little unclear on that. And there's a little bit of mixed evidence on how much impact it has on evading immunity, which we'll actually go into in a little more detail. But it's certainly, what isn't in question is that the impact that it's had. Once Delta arrived in the United States and really started to take off, we have seen here in the St. Louis region a significant bump up, the second largest wave that we've had since the pandemic started, reaching levels that are a little more than half of the peak back in last November. Little too early to say. We've had some flattening, but a little too early to say if we are past the peak or not. We think so, but we also just had kids going back into school in the last couple of weeks, so it's a little too early to say, but it nevertheless has been a pretty significant impact. And this is on a steadily growing vaccinated population. So let's talk about immunity now to SARS-CoV-2. You know, we know that cases, people who become infected, most everybody develops neutralizing antibodies. And we also know that there's a fair amount of correlation between the severity of disease and how antibody titers. People with very mild disease have low titers. Those with severe disease have higher titers. And we also know that they decline over time, just like all infections. When you become, or vaccines, you initially get an antigen exposure, you get high levels of antibodies, and then they do decline over time and eventually stabilize at a level. Some recent studies have confirmed that neutralizing antibodies are still present in most people who've had prior infection a year after infection. You know, cellular immunity almost certainly plays a role. Hard to know how much of a role, how important it is, in addition to the very important role that neutralizing antibodies play. But regardless, we do know that reinfection does occur. Now, there's a growing body of evidence that is starting to tell a story that is not a surprise, that we are getting closer to actually defining what the correlates of immunity are. In other words, being able to do sort of a test, even if it's not easily commercially available yet, but a test to really determine if we have predictable immunity that is durable and effective. And this is generated here on some data that looks at the vaccine effectiveness of several vaccine products and looking at their neutralizing antibody titers. And there does seem to be a very, very strong correlation, such that, you know, we are getting close to being able to say, for example, that for a 50% protective efficacy, that we may be able to have somewhat of a rough neutralizing titer to be able to predict that. But what we do also note, oh, I'm sorry, I went ahead of there, is that prior infection is protective. And this is something that is really, it's not a surprise, this is the way the immune system works, that you've had prior infection, you get some protection. And the data we have so far actually looks pretty good. That for the most part, people who have had prior infection have, in various studies with different methodologies, there looks to be a 60 to 95% protection against future infection that lasts up to 6 months. So one study here in healthcare workers, for example, done prior to vaccine availability, showed that those who were seropositive and previously infected, they had a much lower rate when the October-November spike occurred compared to those who were seronegative. Again, suggesting 80 to 90% protection versus versus infection. Now, however, we're all a little bit nervous about relying on natural infection for adequate protection, partly because what we saw earlier, milder infection does lead to lower antibody levels, which probably means that significant protection will wane more quickly. The other thing is that all of these studies that have been looking at prior infection and its protection, they're somewhat limited, mostly in like healthcare worker groups and ones that we don't have a lot of data in higher risk groups to be able to say with confidence that if a high risk individual had been previously infected, how much protection do they have? What we do know, though, is that those who have been previously infected have a phenomenal response, even to a single dose of a 2-dose vaccine. So, for example, if you look here at baseline, people who'd never been infected before, and then those with a history of infection prior to getting any vaccine, obviously those with prior infection have some antibodies that are present. 1 dose of an mRNA vaccine then gives some antibodies in those who were naive, but those who were previously infected, very high antibody levels, very reliable, such that it actually probably would be very safe to say those who had prior infection, and it's known that a single dose of a 2-dose vaccine is effective. Now, talking about vaccines now, we're switching gears and what is happening with the vaccine story right now. Well, first off, when we're thinking about vaccine effectiveness, there's a lot of different ways to look at it. There's not a single number, there's not a single metric, but there's a lot of ways to consider how well our vaccines are working. First off, most important perhaps, individual outcomes. How well do they protect against severe disease, hospitalizations, and death? How well do they protect versus symptomatic infection? That's the number that we see mostly. Those are the numbers that were reported in the phase 3 efficacy trials. And then how well do they even stop asymptomatic infection, which then presumably would be able to stop somebody from being transmissible or contagious? Very importantly, what are the population outcomes? What about the number of cases and costs averted at a population level? How strong of an immune response is generated? How long does the immunity last? And how broad is the immunity to be able to protect versus even future variants that come on? What's that heterologous protection like? And I will argue that so far we have seen huge success in every single one of these metrics. The vaccines have been a huge success, no matter how you slice the data, even as we are starting to have debates about perhaps some waning, perhaps some need for boosters, which we'll talk in more detail. These have been an unmitigated success. So let's look at the different ways to slice the data on how effective the vaccines are. So for the phase 3 trial efficacy data, these are the ones for the 3 that have been either emergency use authorized or fully approved by the FDA in the United States. The 2 mRNA vaccines, and I use the terms BNT for the Pfizer-BioNTech one and the mRNA 1273 for the Moderna, and they looked almost exactly the same. These were some of the most beautiful figures, in fact, might be the most beautiful figure I can think of in all of medicine in my 20 plus years of doing ID. This graph that first came out was one of the most beautiful things you've ever seen, because it showed unequivocally the incredible efficacy against symptomatic infection, around 94% for those who received the vaccine compared to placebo. And it was almost exactly the same for the mRNA 1273 vaccine. These 2 mRNA vaccines just showed remarkable protection out to 3 months. And then this came out later, the adenovirus 26, which is the Johnson & Johnson vaccine. And had this come out first, we'd have been ecstatic and thrilled that you get 66% protection versus symptomatic infection. It's even higher, over 90% protection in very severe disease and hospitalization and death. And we're thrilled with that. But after the 95%, it's like, oh, hey, this isn't as good. But it's really important to remember that these are symptomatic infections. Some of them are pretty mild. And so that the protection versus severe disease was very, very high for all three of the vaccines that have been released. So the takeaways from these are that phenomenal effectiveness versus symptomatic infection, and even better versus severe disease. And we had no idea how much it protected versus asymptomatic infection because these trials weren't designed to show that. And it only showed follow-up for 3 months. So we don't know about the durability yet. And also the data that were collected here had very little information against any variants of concern. And so that's also a question mark. Despite that, these exceeded all expectations. But then we started getting data on the real world effectiveness once they were deployed in large numbers, particularly in populations that are easy to study, healthcare workers in particular, certainly individuals over age 65 who are the first batch to receive the vaccines en masse. And the data, again, looked fantastic. So this is the more important outcome, right? It's great in a controlled setting that over 3 months you get 95% protection, versus symptomatic infection for most people. But what's really important, do you keep people out of the hospital, especially the high risk? So looking at this, some CDC data here that we had very strong evidence of protection versus hospitalization in age 65 and over for with those who've been fully vaccinated, well over 90% protection in this high-risk population after the first 3 months of vaccines coming out. So real-world effectiveness that's making a difference. Also, it's very close to our hearts, right? All of us working in healthcare workers had very high levels of infection, just like the rest of the public did as well during the peaks in November and December. And then after the vaccination campaign, this is data from Texas, that after the vaccination campaign, those hospital worker cases plummeted and well below what was anticipated if it would have kept on the same trajectory as in parallel with what was happening in the local community. So again, another occupational health impact. And then on a larger population level, modeling has very clearly shown that there has been a significant aversion of many deaths, and estimates are that up until May, even before Delta actually started to have an impact, about 140,000 deaths were estimated to have been averted by the vaccine so far. And again, this was pre-Delta. So we are certainly going to be seeing very strong evidence, I'm sure, by the end of this year that well over 250,000 people will have not died because of these vaccines. And so the takeaways here, again, high-risk groups are highly protected. There's major occupational health impacts and, of course, major public health impacts. Think about the public health, just how many other interventions have occurred where you've prevented death in 250,000 people. So I think this is just, we have to take a moment to say how important these vaccines have really been. But now we're starting to have questions. What about the durability? We're now reaching about 8 months since vaccination campaigns really took off. And we really have to think through, how long does good protection last? And this is a complicated question. So I'm going to go through some data to try to help put some context to it, and then hopefully come up with a few soft conclusions at the end. But here's some things that we're starting to get, more and more, at least antibody data, what happens to these over time. And we're looking at 6-month data, in a couple of the different vaccines. So the mRNA 1273 vaccine does give, as expected, you get a big boost right after immunization, and then you've got some decline over time. And you still see, though, really quite high neutralizing antibody titers. These are when you take sera from those who have been infected, and then you, in a neutralization assay, try to neutralize various variants of concern. And you still see quite high levels of neutralizing activity 6 months out for all of the variants of concern. Delta is this pink one, so that's right here. It's looking pretty good. And as we had alluded to before, this is beta, the B1351, which in every assay that we look at, the beta is always the one that is the most evasive of immunity. But even still, there's reasonable neutralization antibody levels at 6 months. And interestingly, for the AD26 or the Johnson & Johnson vaccine, this data were just released very recently, shows that for reasons that we're not sure we understand, but there's very little decline over time. And this is actually really quite impressive that as many people have been sort of concerned that this vaccine may not be as good, there perhaps is some signal that it is maybe more durable than the mRNA vaccines. Again, we don't know for sure because we don't quite have that much efficacy or true effectiveness data, not quite as much on it as we do with the mRNA vaccines, but this is a promising sign. Now, we do see that they also recently released were the 6-month follow-up data from the original BNT162 or the Pfizer vaccine. The graph on the left is the one that I was so excited about before, and this is the same data that is just now extended out over 6 months. And as you can see, it still looks really good, even 6 months out. And so vaccine effectiveness using the same criteria for symptomatic infections is still very high at the 4 to 6 month range. And so it's not quite as high. It was 95%, 94% before, now down to 84%. But again, a 10% drop in vaccine effectiveness for symptomatic disease. It's still very high, up around 90% for severe illness. Now, we also have another sort of real world example of some waning of effectiveness in this large study of healthcare workers, frontline workers that had been looking at people since January or so, or December, all the way up until August. And that you notice those who had been vaccinated in the 3 months prior, this is effectiveness versus any infection. So people, this was a part of a prospective study then where there was even asymptomatic cases that were identified. So this is actually a very high bar because you're catching asymptomatic cases as well. The overall effectiveness was 85% in the first 3 months. And then you go a couple more months, it's dropped down a little and up to about 5 months. It's down to about 73%. But again, this is a slow decline in the effectiveness versus any infection. So we are seeing, again, some waning of protection versus mild infection, but not, again, any significant decline in serious illness protection. Now, what about, though, the effect of the variants on vaccine effectiveness? Because this is obviously a very important part of the discussion as we're trying to think through whether or not we need any boosters. So here is some data that were presented at the ACIP meeting back in June that is showing that some of the different vaccine induced neutralizing antibodies against different variants. And I've circled here the data that were available for neutralizing antibodies against Delta variant. And there is about a 3-fold reduction in neutralizing antibodies compared to reference earlier variants. So that there's just that just means it's a 3-fold lower levels, which really translates into a very modest reduction in vaccine effectiveness. And you can extrapolate that as well, because if you compare to the data we have against Alpha variant, which we have an abundance of data that vaccine effectiveness against Alpha was very, very good, that it's not much different. That had a 1.9-fold reduction in neutralizing antibody titers compared to the original variants. And so it's not much different, just a little bit more evasive of immunity than the alpha variant. So again, an implication from an antibody level that we're not in big trouble with Delta. The real world data, again, this is the same study I showed earlier with the waning of immunity, but we break it into time periods of basically when Delta was predominant, and that the vaccine effectiveness, again, versus all infection, including asymptomatic infection, is demonstrably lower, only 66% compared to 91%. Although, again, this is indication of even preventing of asymptomatic infection rather than severe disease, for which the protection is still very high. Now, another way to look at this, and another important piece of information that came from the UK, was looking at vaccine effectiveness after either one dose or two. Much of the UK has only been vaccinated with a single dose. They took a different strategy. They tried to get as many people vaccinated with a single dose up front, and then use their vaccine to come back around for a second dose. And so there are a lot of people who have had only one dose there. And what has become very clear is that for Delta in particular, is that and they use the AstraZeneca vaccine, or chimpanzee adenovirus one here, it is that after a single dose, vaccine efficacy is actually not that great for Delta in particular, so that it really does demonstrate the need for that second dose. However, when that second dose is given, and in this case, it's the BNT or Pfizer vaccine, that you have similar vaccine effectiveness against Delta as you do versus Alpha. Again, this is more of a short-term follow-up, but still gives more data, including actual effectiveness data, that Delta in and of itself doesn't cause a significant evasion of immunity if you get both doses of the two-dose vaccines. Now, one more piece of data on Delta here from the UK also showed another, again, against infection that was symptomatic, a drop from 97% to 84%. Interestingly, I also want to point out that in this same study, it does still show, very interestingly, that evidence of prior infection, that but those who've been unvaccinated but only with prior infection seem to have significant protection versus the Delta variant, up around 80 to 82%. And so this, again, is another piece of information that it still shows we do have that our immune systems work and they do what they should, and that's still an important part of our overall, when we think about population immunity, we certainly are measuring the percent of our population who's been vaccinated, but in reality, we have a little bit of a cushion there, because many of those who have been previously infected, especially recently, will also have a measurable level of immunity. One other piece of information is just data that was released last week that, again, reinforcing the idea that our vaccines are still quite effective versus Delta, is information from Los Angeles County at a population level that showed about 5-fold reduction in the risk of infection in Los Angeles County for those who've been vaccinated versus those who hadn't. And then, even more importantly, a marker of more severe disease, that you get about a 29-fold reduction in the risk of hospitalization if you've been vaccinated compared to if you haven't. So, and this is during the Delta surge. So again, more and more evidence that the vaccines do provide still excellent protection versus the Delta variant. However, there's been a lot of conversation. In fact, maybe the number one topic about coronavirus now is when and if we need any boosters. And the reality is, as we've just been seeing, is that the vaccine effectiveness is starting to wane, and that happens. That's normal. It happens with natural immunity, happens with vaccines. But you need to remember, what are we protecting against? So vaccine effectiveness versus symptomatic disease, the thing we are most seeing a waning in, is important, but we really haven't yet seen any significant drops, although there may be some signal of this that's been happening in Israel and older individuals in particular. But for the most part, though, we haven't really seen really significant drops in protection versus severe disease. And so, we also are a little bit confounded here because, there's maybe a tiny little drop in effectiveness in Delta compared to prior variants, especially for those who may have only had one dose of a 2-dose regimen. There's also some thought too, that we have such high viral loads and there's so much more virus that is being expelled and thus accounting for Delta's higher transmissibility, that we might be seeing a model here that we are giving injectable vaccines, which generate extremely high neutralizing IgG levels, but we don't necessarily see really high IgA levels that are mucosal. And so we maybe have developed a model that it's maybe unrealistic to expect we're going to stop all infection, because through injectable vaccines, we may or may not be able to get high enough IgA levels to protect any sort of binding and local replication in the upper airways, and that we may still, though, have phenomenal protection against progression to more severe disease. And so we have to really define what's our target of success here. What is it? What's our goal? What are we trying to do with the vaccines? Nonetheless, we do have some concern that, as we know with all infections and with vaccines, that with immunosenescence, that those with older immune systems, that antibody protection does wane over time more quickly in those who are age 65 and older. So when we put all of this together, it's unclear right now who needs boosters and when, although there is some significant concern that the CDC is very seriously looking at right now. And I should add, and I want to clarify, that there's been talk about making the boosters available for people starting in a few weeks. That is a goal of the administration. However, the FDA and the CDC have not yet made a determination that this is something that we can or should do. But in thinking through this, this is just an example of the antibody kinetics that occur after vaccination. So you get your baseline here, you get your full vaccination series, you get high levels, they start to decline over time. Now, what we know is that there's a certain antibody level, and we're getting closer again, as I mentioned earlier, to defining what that correlate of immunity is. But it's at a certain level, whatever that level is, of neutralizing antibody titers that protect somebody versus severe disease. And as of right now, even 6 to 8 months out, for most people, especially those who are under 65, it doesn't seem to be anywhere near falling below that threshold. What we're starting to see, though, is perhaps at 6 to 8 months that some are falling below the threshold of the neutralizing antibody titers need to be, there's a higher threshold that would be needed to prevent symptomatic infection. And so we're starting to see that evidence. And then, of course, you really have to have a very high bar with very high neutralizing antibody levels to prevent asymptomatic infection. And so we are somewhere living around this line right here of starting to bump up against the area of where some declines in symptomatic infection are occurring, but again, even still not widespread. So where does that leave us? Well, we have to make some decisions. What's the best use of our vaccines? So right now, I would argue, at the moment, at least, that it's a higher priority for us to get first and second doses into people rather than third doses, because that's where the difference is going to be. Delta is wreaking havoc. Right now, if you're unvaccinated, your risk from Delta is higher than it's been throughout the entire pandemic. And if you look at the case rates that we have, we were 60% of our peak back in November, but that's with half our population vaccinated. And so you could imagine if Delta had run through 8 months ago, how terrible those numbers would have been. We were hitting 120 COVID patients at Barnes Jewish Hospital back in November, and it may have been 200. I mean, it would have been just terrible. So it is a very nasty virus for anybody who's unvaccinated. So we need to get more people vaccinated. And that's the key. So pediatric approval will help. It looks like we're on track for probably sometime, maybe November, but hopefully by the end of the year, there'll be an emergency use authorization, at least for one of the mRNA vaccines down to age 5 or 6. And that we've also seen that the FDA approval of the BNT vaccine has triggered more workplace mandates, school mandates. That's going to bump up that the overall vaccination rate as well. But we still have significant issues with access, both in rural areas and also in some urban areas as well, and significant hesitancy. And so I'm going to argue that at the moment, we would potentially have more benefit, even in the US, if we were to be able to use our excess vaccine supply to be able to prevent global cases, because the more time that this virus spreads and the more cases that are occurring, it increases the risk of more dangerous variants developing. So we have a vested interest in reducing the global impact. And so I think at the moment that might be the best use of what vaccines are currently available. And to do this, though, even in the US, like I mentioned, only 52% of the population is vaccinated. And so there is a lot of vaccine hesitancy. Now, obviously, if you're under 12 years old, you don't have a choice. But if you're over 12, you do. And certainly those who are old enough, where they don't have to have parental consent. But the reasons for this, I want to just touch on this briefly because it's really important. Most all of you, I would bet, have had conversations with family or friends about this. I know I do. I've got, a brother and a brother-in-law that I have spent hours talking to about there because of the information sources that they hear, that trying to say, hey, it's better to get the vaccine than to not. But the reasons for hesitancy, it's really important. And this is work that was done by Elvin Gang here at WashU as a really good study that looks at and really helps to delineate that it's not all vaccine hesitancy is created equal. There are categories and there are some predictors of that. So for overall hesitancy, the main predictors were female more than male, Black and multiracial race, middle-aged and living in red states were predictors of vaccine hesitancy. But there's very different hesitancy based on those demographics that correlate with the different demographics. So some are just reluctant. They want to say, wait and see if it's safe. And that category, we've actually seen a very steady increase in vaccine acceptance over time as there's more and more safety data, as we've seen the overall effects of vaccine working very well. But then there's also the group that are vaccine rejection, not reluctance, but rejection based on either distrust of the vaccine or distrust of government in general and dissent. And those are a little bit harder, but either way, the approach, some things, the approach is maybe a little different because, for example, if you're wanting to give important, reliable information to somebody who doesn't trust the government or doesn't trust vaccines, in general, especially not trusting the government, you don't want to just start off saying, well, the CDC says, because that right there will be a non-starter. They don't care what the CDC says. In fact, if they don't trust the CDC. So you want to be able to then use story and anecdote. But regardless, one of the ways, of course, to help reach people who are still hesitant is one, listen to what their concerns are. And if you can't identify who can be a trusted messenger. People listen to who they trust. They, they're not going to, just have somebody come in, oh, it's like you're some big WashU doctor, you're going to come in and tell me what to do. That may not be effective for a lot of people. But if somebody in their community, maybe a church leader who is able to talk with them or somebody, a trusted friend, that really makes a difference. It's stories, it's anecdote. We're all anecdotal creatures. And so anecdote and story is also very powerful, even for us in medicine, as we give factual, accurate information and can direct people to that information. Don't forget the power of story, because everybody still is impacted by anecdote and story. And so I'll just finish up by saying, where do we go from here? And who knows? I mean, predicting this is fool's, sort of a fool's errand, but I'll do it anyway. And the idea, here's what I think is going to happen, or what's going on, is that, it's very likely that we are going to see some seasonality of this virus. And eventually, it's likely that we will see, winter spikes in COVID-19 activity. Now, of course, there's extreme wildcards that come into play. If we get a variant of significant concern, of high concern, then that could change the game, obviously. But in the absence of that, or even with, sort of some degree of that, once we get enough of the population vaccinated, I think a lot of us believe that this is going to be what we see with influenza. Every year, we're going to see, a season. It might be a bad season one year, it might be a less bad season, but even in less bad seasons, as we've learned with flu, it's going to have significant morbidity and mortality associated with it. And I do believe we're rapidly reaching the point that avoiding all infection with COVID-19 is not going to really be feasible or possible. We've been trying to do that. That's sort of been a mantra for many people. Many of the public health objectives is to avoid infection. This was particularly true before we had effective vaccines. But as we're seeing, this virus is going to be with us forever, almost certainly. We're all going to be seeing coronavirus in our lives, the rest of our lives. And it's probably likely that, at some point, we're all going to be infected with this. The goal is to make sure we've got enough individual immunity and enough population immunity such that it will minimize the public health and individual health impacts. And so at the moment, and this is conceivable, because at the moment, if you're unvaccinated, this is a much worse disease than flu, much higher risk of death, especially if you're even over age 40 and even younger individuals, that this is a very serious infection for unvaccinated. But the good news is these vaccines work so well, they work way better than the flu vaccines. And so again, the key to all of this is just getting the population immune. And ultimately, we're going to need to learn to coexist with this infection because it's not going away. Okay, well, I have certainly used up a lot of time talking to you, and I would really love to hear what kind of questions, thoughts, concerns people have, and I'll try to tackle anything.
Perfect. Dr. Lawrence, thank you so much. First of all, what a fantastic talk on an important subject. We really appreciate you giving it for us and your expertise in this area. To start off with a couple questions in the chat here, I see, isn't the increase in pediatric hospitalizations a suggestion that Delta is more virulent?
Yeah, there is some signal that it might be a little bit more virulent. There's been some signal in Scotland where the risk of hospitalization is a little higher with Delta than others. Although I think that one of the other ways to consider this is that right now, the largest proportion of people who have no pre-existing immunity are in kids. And so with a virus that is twice as contagious, say you would have twice as many infections, even less common events like hospitalizations are going to be twice as likely. And so I think that it is a little unclear how much more virulent this is for children. I think the overarching sense that most people have is that it might be just a little bit more, but what most of the additional morbidity that we're seeing with it is more accounted for just by the sheer numbers that are being affected in the unvaccinated populations.
Another question asked, is there utility in checking spike protein antibody levels, such as the antibody level we're sending to Mayo to determine a person's immunity, to determine if a booster may be needed?
Yeah, unfortunately, we're not there yet, because for one thing, the commercial assays look at just IgG binding antibodies, and we don't really have, we know even less about what level of those would correlate with immunity compared to even neutralizing antibody levels, which are much harder to do. Those are functional assays that aren't commercially available and are very time consuming and expensive. So, and we don't even yet have an exact definition of what level of neutralizing antibodies to protect. So I think it is premature, and I don't think we can predict much by looking at anti-spike IgG antibodies.
You started to touch on this a little bit, but can you comment more on the recent data from Israel, where they're reporting a higher percentage of hospitalized patients having been vaccinated?
Yeah, so there and there's a couple of different things that have been coming out. Certainly, Israel has been a unique opportunity because they have a nationalized health system. Everybody got the same vaccine, and they have very high vaccine uptake rates very early. And there have been many studies. In fact, a lot of what we've learned about waning immunity and the effectiveness, particularly of the BNT vaccine, is from Israel. And so we are seeing increases in hospitalizations over time, particularly in some older individuals. And that has been, again, some of that drumbeat of concern that has led the CDC to really start to be a little bit nervous about whether or not those antibody levels are declining in some patient populations to a point where we do need to be concerned about it. But again, it's also, there are still some unclear signals. We haven't seen this yet in other places, but because that may be a harbinger of what's to come, that is part of the reason why the approach is being looked at for older individuals in particular. And I think my takeaway from this is that it's, one, we know that immunocompromised individuals do need a third dose, but that's not really a booster. It's really just to give a primary dose to boost it up. But then the over 65 probably does need a booster soon, sometime in the road. But for the vast majority of people under 65, though, is really what my main point was, that I don't think that there's much evidence that we need to, at this point, rush to get a booster.
You mentioned a lot of data about vaccine efficacy in symptomatic infection and severe infection. Is there anything that's known about the impact of vaccine on reducing or preventing long COVID symptoms?
That actually, I haven't seen a lot of data on that yet. There's been some interest with breakthrough infections. Anecdotally, it happens that there's certainly people who have been having some breakthrough infections that have symptoms that last for a while, but we definitely don't have enough data for it yet, partly because Delta has really been the source of most breakthrough infections since the vaccination campaign started. And this has really only been circulating in high levels for a couple of months. And so we don't really know yet about long-term symptoms until there are more people who have recovered for more than a month or two. So it's a little unclear yet how much vaccine will reduce the risk, hopefully, of long-term symptoms, but we just don't know yet.
Speaking of breakthrough, is there a greater benefit to focusing vaccinating in the areas of highest transmission, such as the US and India, rather than in less endemic areas first?
Yes, I think that is an important part of a global strategy as well, is to, again, focus where there is high levels of transmission. Absolutely. Yeah, I think we need to, get high levels of vaccine uptake in as many areas as possible. Now, part of it is, though, that's reactive. Because once you already have high levels, and by the time you ramp up a vaccination campaign, it does take a few months to do so. And by then, the natural epidemic curve is already faded. So it's a little bit like you're a little behind the game if you're only going after places that already have very, very high levels, although it is still important to hit those areas.
What do we know about folks that in their antibody response for those that develop a breakthrough COVID infection after vaccination, as compared to folks that had COVID infection and then vaccination?
Yeah, I actually haven't seen specific data for that instance, but it's very likely to be quite high because although one thing we do have some data on is that, and this isn't any surprise either, is that there is a higher risk of breakthrough infection in those who have lower antibody levels, and the previously vaccinated, and those who do have breakthrough infection have lower antibody levels than a control group that hasn't had breakthrough infection. But there is very likely to be boosting of that. There is precedence and some scientific plausibility that when you have similar but slightly different antigens, either from natural and then vaccine infection or different vaccines, that you may actually get a more pronounced immune response.
A question here, kind of asking about WashU's data. Are there neutralizing antibodies the only way to look at the amount of protection for the vaccines? And what about the WashU bone marrow studies that have been done?
Well, so yeah, so Ali Alabedi in his lab and my colleagues, Rachel Presti and Jane O'Halloran, have done some great work and looking at and determining that both natural infection and vaccine stimulate the germinal centers, and you get super massive stimulated B cells that are just remarkable. And those last for at least 3 months, where these germinal centers are active and you basically have these massive B cell activity. And so that too is also a factor in reassurance that you are still getting at least humoral antibody or humoral immunity that should be sustainable and lasting. Of course, that's not something that's readily measurable with doing lymph node biopsies on people to assess how much residual immunity they have.
What is known about the cellular immunity to COVID and the COVID vaccine?
Yeah, and certainly it's almost certainly important, but just like most every other viral infection, especially respiratory virus infections, that the correlates of immunity are less well understood. We do see that people who don't generate T cell responses do tend to have less protection, but it's just not as well defined and a little harder to quantify.
You mentioned a little bit about this with the maybe upcoming approval, at least EUA for children. Someone in the chat mentions, could a pediatrician use as, quote, off-label use since it's now approved for adults?
The FDA has advised against this. They're still, the reason they're doing the studies is to look for safety and effectiveness in that age group. And so the FDA has actually explicitly come out and said, don't do that.
Is there any information about boosters for the Johnson & Johnson recipients?
Yeah, there are data. Actually, I think this should be coming up pretty soon. So my colleague, Rachel Presti, has been working with this as well. And so there should be data on the second dose for the adenovirus 26 vaccine. And it does as expected. There's been, certainly there's been some data released that you do get effective boosting of the antibody levels, which you would absolutely expect to see. How much extra efficacy you get is still something that we're eager to see.
Do you have any comments about the Sinovac vaccine coming out of China?
Well, there's just yesterday in the New England Journal, there was the study that came out for this inactivated vaccine. Studies on it look like it's probably in the 50 to 65% vaccine effectiveness, depending, and certainly, depending on which variants are predominant in the countries where they're studied. So it probably is effective and not quite at the same level as our mRNA vaccines or the adenovirus vaccines, but it looks like there's evidence that is of some effectiveness.
I think we've covered most everything we can, and we're just about out of time. So once again, let me just say thank you so much, Dr. Lawrence. Really appreciate your expertise and your talk today. It's been very helpful and effective for all of us. So thank you again.
All right. Thanks for the opportunity to talk to everybody, and be safe out there.
Yeah, we'll do our best. I'll leave my screen up for a little bit for anyone that needs the QR code. Thank you all again for joining us. As always, once again, please come to our YouTube channel to see this talk and other talks we've had previously. And please join us next week. We're actually going to have the first in-person option for our Grand Rounds talk next week. Folks, a limited number will be available to be present in Holden Auditorium in the FLTC. Obviously, we're going to social distance and mask, so we may not be able to accommodate everyone, but it'll be nice to have a few folks in chairs and to have a great talk for the Slatopolsky lecture with Dr. Deirdre Cruz. So please join us. Thank you all.